Hello everyone, I'm Suguna, Assistant Professor from Computer Science and Engineering Department in SNS College of Technology. So, welcome to this session on replication, sharding and backup in MongoDB. So, in today's video, we will understand how modern applications handle the huge data failures and performance issues by using MongoDB. So let's start with an ice-breaking session. So let me ask you something. What if one day you open Instagram and all your photos are gone? Or imagine a banking app where your transaction history disappears. This is not just a small bug, that's a serious data disaster. So the question is, how do companies prevent this? That's exactly what we are going to explore today. So the problem statement is in real world application, the system face multiple challenges like servers may crash at any time and the data grows continuously, which means the amount of data accumulated on the server or growing day to day. Risk of data loss is always there when we take any kind of data or any kind of database or data set. So we need the system that provides a better safety for data, high performance on reliability and scalability, and also there must be a security. So let me empathize this problem statement. So let's think of from both sides. So when we think of from user perspective, the data which is stored by the user on any database should never be lost, and application should always be available to the user whenever they require. And when we think of in the aspect of organization, companies worry about mainly on three things, which is about their data loss, their downtime, and their slow system. So clearly, we need a robust solution for both user perspective and also for the organization's perspective. So let us understand what are all the challenges we face in this kind of problem. So here are some of the main problems. So if one server, what happens if one server fail? If one server fail means the complete data will get lost. Next, the larger data set will slow down its performance and or the throughput from this server becomes very low. So you know what is meant by throughput, the number of data retrieved per unit time. So the backup is necessary for recovering these kind of data. Database changes become very difficult on the later. So depending on a single server is very dangerous, right? So let me provide solution for this problem statement. So let's evaluate some solutions. Store everything in one server. So when we store everything in one server, that becomes very risky, right? So we can go for manual option. But when we do manual backup, it provides slow and it is not also reliable because a human may do some mistake and they miss some data. So the best approach is to use the distributed system, which is the powerful technique for managing replication, sharding and backup. So what is replication means? To keep copies of the data for safety. Sharding means splitting the data for better performance. Backup means help to recover the data which is get lost. So this is the prototype workflow. That means let us understand how these three concepts work together. We know the replication means it copies the data across server. Sharding will distribute the data across the machine. Backup will store the data for recovery. Together they create a highly reliable system. So this is the prototype workflow. And next, here we use Node.js with Express and Mongoose. The key part is connecting the strings. We connect to multiple Mongo instance using a replica set. This ensures if one server fails, another will take over the application, continues running smoothly. So replication ensures high availability. Next, look on the data and backup. Now we define a simple user schema with field like name, email, and age. So then if we implement a backup API using MongoDB, so when this API runs, the database backup is created, data can be restored at any time. So the backup will ensure the better data recovery and also the safety. And what will be the outcome of this input means with this system, the data will be highly protected. The system performance will get improvised and the recovery is highly possible. This is how real world application manages the large scale data by using MongoDB. So applications, when we look on to the application, these concepts are widely used in banking system in order to do secure transaction and in social media to manage the data of millions of users and in e-commerce platform to manage to store and retrieve the data which are related to product and also user data. So cloud storage, this is a large scale storage. So these are some of the industry level applications of MongoDB. When we come to testing, let's verify the system. So stop primary server means the secondary server becomes the primary. When we insert a data, synchronized, it should be synchronized across replicas. When we insert large data, it should be distributed using sharding. When we need backup means it should be successfully created. Restore means the data has to be recovered. All tests will get passed, proving the system is reliable and efficient. So let me recall, let me have a quick summary. Replication means data safety, sharding means scalability, backup will provide the recovery. Together they form a complete data management solution. So in order to understand these concepts, let me have an activity. I will give you an activity, you just try it out. So now it's your turn to practice, right? So you just create a sample database, insert some data and perform backup using MongoDB and you observe the data, what happens. Okay, so bonus task. So apart from this, I will give you an additional task, that is find out how many companies like Google or Amazon is using this replication concept. When you find solution for these two questions, moreover you clearly become a better idea of what is replication, sharding and backup. So to conclude, replication, sharding and backup are essential for building scalable, reliable and fault tolerant applications. So thank you for watching. If you have any doubts, provide me on comment section. Thank you all.